Hello, everyone. Welcome back to the Polkadot deep dive session. So this time we are covering NFT palettes. As we all know, NFTs are getting very popularity in the market. So this time we'll be exploring what NFT palette, what features we have in the palette, and what are the new features come into the NFT 2.0. So uh, hello everyone, I am Pawan Best, working as application engineer at Polkadot. Sorry, working as an application engineer at Parity. I'm presenting this session along with Bruno, working as a support engineer, and Alexander, as a working as a solution engineer. So let's get started. All right. So let's start with the objective. So the objective of these sessions are to promote learning and share knowledge about frame palettes and substrate tooling. As we all know, like in the substrate frame, we have around like 50 plus palettes available that form a solid starting point for any substrate based chain. So the major intention for these sessions are to promote learning and to add one extra topic in our knowledge pool. So this is our agenda for today's session. Like first, we'll be covering the palette, the high-level overview of it, high-level features of NFTs palette, the dependencies with other palette, like how it is dependent with other palettes. And then we'll be seeing like how it is being used in Polkadot and Kusama runtime. After that, we'll be having a deep dive demo from the Bruno's endpoint, and then at the end we'll be having the code walkthrough session from the Alexander's end. So before going into the palettes NFT directly, first what we'll do, we'll understand what NFTs are, how they work, and what are the advantage, or what we can say, like what exactly and what specific this term is, right? So let's start with the NFT. So basically, NFT stands for non-fungible tokens. In a simpler term, if we say NFTs are assets that have been tokenized via blockchain, and they have like unique identifier. They are assigned with a unique identification code and metadata that distinguish them with other tokens. So basically, NFTs are digital representation of physical assets. Like it can represent like digital assets or real world items, like for example, music, artwork, GIFs, videos, and much more. Right. NFTs can also be traded and exchanged with other cryptocurrencies or other NFTs. If you talk about the major property of it, like unique, they are unique, right? So as per the definition here, they are unique cryptographic tokens that exist on a blockchain and cannot be replicated, because we have the unique identifier for that, which is directly linked to a blockchain address. They are neither be replaced or interchanged, right? Now, if we talk about some history, like for example, from where this term came and what is the history, like what was the first NFT sold in the market? So the first NFT sold was Quantum. It was basically designed and tokenized by Kevin McCoy in 2014 on a blockchain called Namecoin. And after that, the NFT is minted and sold on 2021 on Ethereum. So this is how NFT, and since then NFT is getting very getting popularity into the market, and now everyone knows like what are NFTs and they are performing in the market, right? So now, as we know, like these are non-fungible tokens, right? So what is the fungibility here? Like what is the difference between fungible and the non-fungible? So as the image shows, like here we can see two bitcoins, right? They are one bitcoin is equal to to another, and if you see, we have two similar images as well, but as per the image, they are not equal, right? Why they are not equal? So if you talk about like physical money and cryptocurrency are usually fungible, it means like they can be traded or exchanged one for another, right? For example, one Bitcoin will always equal to always equal in value to another Bitcoin on a given exchange. But if you talk about the non-fungible thing, non-fungibility makes every token unique and irreplaceable, and makes it impossible to to be equal to another non fungible token because of its unique property. And if we say even we create thousands of NFTs for a similar for NFTs of the same set of data, right? Still, each token will have unique identification code, and they'll be distinguished from each other. So that's why NFTs are irreplaceable. That's why we say NFTs are irreplaceable. But the one property we have in NFTs are like they are extensible. Like what we can do, we can create, we can combine one NFT with another in order to create the third unique item. So this is the difference. We can say the way what is non-fungibility and what is fungibility. Like they are irreplaceable in a simpler term. So now understand how NFTs work. So basically, if you see in the image, we have NFT, and then basically, if you go from left to right, NFT creates a digital blockchain-based digital signature of the collectibles. Right. This digital signature is unique. Basically, like we can have anything like gaming items. We can have music. We can have artwork. We can create digital assets of anything. Right. In the NFTs, basically this is what NFT is. If we talk about NFT, how they work, basically NFTs are minted or like created through a process called minting, which actually stores the NFT information. Like basically through this minting process, NFT's information is stored or recorded into the blockchain. And if we say from the higher level, like how they are created, like every NFT, like in the minting process, basically minting process entails a new block being created. Then that block, the NFT information is being validated by the validator, and the block being closed. So this is the kind of a process of minting. This is how it will go from left to right in the image also. And as tokens are minted, then they are assigned with a unique identifier, which is directly linked to a blockchain address. And each token stores the owner details and other relevant information in the metadata, right? Basically, if we say NFTs are basically represents the ownership of any collectibles, whatever we have, right? If we have the NFT for that, if we convert that into an NFT and extract it or create a digital signature for that, then we'll be having ownership, and we can secure that thing. But if you say, are they safe or not? Like if we create NFT for any of the collectibles, are they safe? As we know, like they use blockchain technology, right? And we know like technologies are kind of impossible to hack. But the weak link we have here is the keys, right? The private keys we have. If our keys are not secured, or if keys are being hacked by someone, right, then definitely our NFTs are not safe. They can, like for example, if the key is not with us, then we cannot do anything, right? So this is how NFTs are secure if the keys are secure, right? Now this is all about the NFTs, like what NFTs are, how they work, uh, of which collectibles we can create NFTs and all. Now let's talk about the Pallet NFTs we have here. So this is the Pallet introduction. The Pallet is basically a simple, secure module for dealing with non-fungible items, and most of us knows like we already have the unique Pallet available available with us, right? That is also dealing with non-fungible items. So why this Pallet NFTs? What is this NFTs 2.0, right? So if we talk about in a simpler term, NFT 2.0, this Pallet NFTs is complete rework of unique Pallet with some additional features. So we'll have everything which whatever we have in the unique Pallet, but with some additional features. That's why this is NFTs 2.0, right? We'll talk about those additional features in the coming slides, where we'll see the high level features of the Pallet. But before that, let's understand the goal of the NFTs Pallet, right? Goals are like, firstly, it allows users to permissionlessly create NFT collections. We have here functionality to mint and burn unique items. We can also freeze and unfreeze collections also. we can easily transfer NFTs from one account to another. And as we have the metadata available in the NFT, we can store some information on that also, right? With a unique identification code, we have the metadata available as well. We can store the information there. In NFTs, Pallet, our dispatchables are categorized into four parts. The first one is the permissionless, the second one is the metadata, the third one is the force, and we have permission, right? The other, like the parts are marked into red, are all are permission basically. Like some are with the some additional enforcement, and some are with the basic permissions. But the green, the permissionless, is like kind of permissionless. You need to have a signed transaction with some available funds on it, and you'll be able to perform that operate those operations. The items we have in the these categories is like the first one, like in the permissionless, you can create, mint, right? You can transfer. Whereas in the metadata, like this time we have smart attributes, like we have metadata management as well. So we have set attributes, set metadata kind of things. In the fourth, this is we'll see like how this enforcement is being injected into the configuration, like in the configuration section. The extrinsics come under the force category, is like force create, force collection, create kind of things. And in the permission, we can have destroy, burn, and so on. We'll see the list of things in the demo, or in the code walkthrough session, right? So this is the category. These are the four categories we have for the dispatchables. And if we talk about the high level features we have in the Pallet NFTs, like it allows like collection creation, right? We have the minting process, like creation of NFTs. We have transfers and atomic swaps here, and atomic swaps are not present in the unique Pallet. We have multiple trading methods. We have smart attributes, right? Attribute management and the burning. Now, these are the major high level features of it. If you talk about how it is different from Unix Palette, is like we have atomic swaps here, right, in 2.0. Here we have authority, or we have a way to set different minting options here. Our collections ID, which is used in the source code, or at the creation of that is auto incremented here in the NFTs 2.0. We have smart attributes, and some other additional features as well. So this is how these features are making NFTs different from the Unix palette. So these are the features comes over the Unix palette, right? Now, if you talk about this is all about the like features, high level features and all. And if you talk about the dependency section, so NFTs palette is basically dependent on the frame system, frame support, and palette balances. We can see more in the configuration sections, like how they are dependent. Like these are the basic frame system, and I would say support are the major basic ones for each palette. But here, as we are dealing with some balances thing also, that's why we have the palette balances, and then it is being used in the runtime, the configuration. So this is how it is being used in the Polkadot. I would say, like first thing, let me clear one thing here. The palette NFTs are being used, like this palette is being used in the Westmint, the Western testnet network in the Polkadot, and we have in the state mine as well. If you see, so this is the Westmint's configuration for Pallet NFT. We can see here the major one is that this collection ID is auto incremented here, and the runtime event is common for all. We have currency type here. That's why we have the dependency with the balances palette here. This create origin and force origin are used to make the dispatchables permissionless or permission. Like basically create origin is being used. We are just using as ensure signed here with account ID, so that is being used on the permissionless as well. But if you talk about the force origin, this assets force origin, it is mainly used on the permissioned dispatchables, right? If you talk about the what is this assets force origin, so it is just defined as a root, ensure root, right? Only the root privileges users will be able to perform these operations. Apart from that, we have this collection deposit, item deposit, metadata, attribute deposit, deposit per bytes, and the max deadline duration, right? These all are configurations we are reusing from the Palette Unix. In the next slides, we'll be seeing what are the parameters we have, like what are the meaning of these parameters. So these are being reused from the Pallet uniques. Once that Pallet uniques in future maybe once that is deprecated, then we'll be having this configuration particular to the Pallet NFTs. Apart from that, we have just signature things, so the option signature, option public, and some constants. This is the configuration for this, and how this is the actual configuration of the vestment, right, in the Polkadot testnet. And these are the parameter types. The next one is the actual Pallet NFTs parameter types. The first one is the unique Pallet parameter type, and you can see here all the attributes we have available, all the parameters we have here is being directly used in the parameter list of the Pallet NFTs. So basically, we are reusing these, right? So this is how the configuration is being used. This is how the palette is configured on the runtime. And with a palette index of 52 in the, you can see here in the constant runtime, NFTs is indexed as a 52 and unique is a 51. So basically NFTs, this palette is the 2.0 version of NFTs, right? This is how the things are used or configured into the runtime. So this is it from the overview perspective of the palette, the high level feature. Now let me pass the control to Bruno so that he can provide you or give us a deep dive demo of like how to play with the palette NFTs and like what are the other things related to it. Over to you, Bruno.
All right. Thank you, Pavan. Thank you for that amazing introduction for NFTs Palette. And my task here is that I want to show you a demo of the NFTs Palette. The NFTs Palette has many, many features. So as Pavan hinted, there is the uniques palette, right? You can think of that as like the NFT 1.0 palette. And NFT palette is what we consider like NFTs 2.0 palette. And the way that it came about is that we looked at the uniques palette and we said, what are all the features that are out there that's happening right now in Web3 in terms of like NFTs? If we were to rebuild this palette to encompass all these features, what would that look like? And that's where NFTs palette came along. So I invite you all to actually look at the code for the NFTs palette because there's a lot of features. And in fact, in this demo, I'm only going to cover one specific, very, very interesting feature. But let's start, even before I show you the demo, let's actually start here with a little bit of an overview of some of the interesting thing of the NFTs palette. So also want to share with you that it's in the Polkadot wiki under Learn, Advanced, and NFTs palette. So this is an excellent read. I recommend it to anyone who's interested in building around the NFTs palette. We will cover a few topics here, like for example, roles. So when you're setting up a collection, there are certain roles. So for example, there's the owner role, and the role of the owner, they can do certain things such as destroy the collection if all the items have been burned. They can do things as setting up the team, setting up who's the issuer, who can issue NFTs, who can have administrative privileges, and who can freeze and unfreeze NFTs. So setting up the team is part of the role of the owner. So when you're creating a collection, these are things that you want to think about because this palette is highly configurable. It's really, really, it's super configurable. And so there's many, many use cases for this palette. One of the roles when you're setting up a collection is admin. So you have to state who's going to be the admin. The admin is the person or the account that will be in charge of setting the attributes and metadata for the collection. They're also the account that can pre-sign modifications of the attributes. So this is also what's known as off-chain attribute modification. Okay, this is another terminology that's used for this, so that you can update attributes off-chain. The admin is also the account that has permissions to lock the item metadata and attributes. So depending on the type of NFT product you're building, this might be interesting. The other role is freezer. So Freezer has the power to lock the item transfer, so no item transfers are allowed, and they can also unlock. And lastly, the last role here is issuer. The issuer is the one that can mint. The issuer is also the one. So when you create a mint, there's a mint settings that you specify. The issuer is the one that can update the mint settings, and the mint settings is what the mint extrinsic uses. However, the issuer has also the power to force mint, which means that they can actually force mint an NFT and override the default mint settings that were set previously. The issuer is also the one that can pre-sign NFTs. So this is also known as off-chain minting, which happens to be the demo today. Okay, so I'm very excited for that. So these roles, when you're setting up a collection, you can set one account for, you can set an account for owner, admin, freezer, issuer, or you can set the same account for all of them if you want, or you can set some of these or all of these to none. So these are things that you want to think about when you're creating a collection, because setting some of these to none could be useful, because by setting the roles to none, it says here, we remove the possibility of minting any more items, changing the metadata, or disallowing some items transfer. So for example, when a collection is created and all the items are minted, so you minted all the items and you set all the roles to none, so that's done, no more modifications. So if that's your use case, setting them to none could be interesting, right? So it really depends what you're building. And this is an example of how the palette itself is configurable. One other thing that I want to note is that when you're creating a collection, you define a settings for the collection. And this settings is actually, it's in bit flag format. If you look at the palette code, you'll see the bit flag format. Maybe I'll show that to you. And part of the settings, the default setting is that all of these are enabled. So for example, transferable items, well, by default, items are transferable. By default, metadata can be changed. By default, attributes can be updated. By default, max supply can be changed. Okay, so that's the default setting. Now that may not apply to your use case. So that's where these settings are configurable, and you can say, well, in my use case, I don't want to allow transfers, or in my use case, I want to lock the metadata, and I also want to lock the attributes, but I want to enable transfers. So it's up to you how you combine these. And you can actually see, let me show you the code. I have it here really quick. So inside substrate, inside NFTs, source, types, you're going to see a section here where you're going to see bit flags and collection settings. And you can actually see right here what we just covered, transferable items in the collections are transferable depending on the bit flags that's set for this. Okay, and you can see the other options here. So that's there in the code. Really nice to review this and see how the bit flags are used. Bit flags is something that I think we're going to see more and more in substrate and palette development. And those of you who are developing palettes, I actually really recommend bit flags. It's really efficient and nice. One note on the bit flag is that the Polkadot.js apps, it currently doesn't have like the best UI to support bit flags. So you're going to see that when I create a collection, it accepts a positive integer. So you'd have to do the bit flag operation and then manually convert it to an integer and submit that. I'm just going to set it as the default bit flag of 0, which is the default value, which in the default value is that everything is enabled. Okay, so when I do the demo, you're going to see that. Which, by the way, for this, I actually created an issue on the Polkadot.js apps to support bit flags. And so hopefully this will be, we'll have a nicer UI around that soon. Okay. So this wiki article here, it goes on and on. It shows you some examples of uploading files and setting metadata. I recommend that this is an excellent read if you're new to the NFTs palette. So take a look at that. So let's get started with the demo. So First thing that I want to do is I actually want to show you off-chain minting, because this is a concept that we've gotten a lot of questions about, of like, what is off-chain minting? How do you do it? And so I think this is an excellent demo to do to share with everyone. And it's just one of the many, many features in the NFTs palette. Okay. So you can see here the actual PR. I'm always excited to show you the actual PR where the developer here actually implemented this. And you can see it says the PR adds a new way of minting NFTs with pre-signed data. So it says, as the collection's owner, you can pre-sign mint data. So you pre-sign the mint data and pass the signature to the end user, who would submit it on chain. The item's mint and metadata attribute deposits will be taken from the end user, right? So we're going to take a deep dive into this and see what this is all about. So first, what I'm going to do is I'm going to spin up a node, a substrate node that has the NFTs palette configured. So let's do that. All right, so that's spinning up. Soon it'll be producing blocks. And let's go back to the app here, open up Polka.js. Also want to open up another Polka.js tab as well. And we can see here, okay, it's producing blocks. Recent events, none so far. The previous tab is there. I also want to create a third tab. And we'll put it together here so all three tabs are together. And that's connected as well. All right, perfect. All right, so we have a substrate node running here. It should have the NFTs palette. So let's see, go to extrinsics. And I'm going to be doing the demo today under Alice. Let's look. And we have NFTs. So you can see these are all the extrinsics. You know, some of them may be familiar to you, like burn. We're talking about claiming the swap. Like earlier, we're talking about atomic swaps. That's one of the features that's part of this palette. You know, we can create a swap, claim the swap. And there's many other features here. Okay, you can see there's the mint. There's tipping. This can be used for voluntary payments of royalties. You can set the collection max supply, set the metadata, set the price, set the team, do a transfer the ownership, and update the mint settings. What we want to do first is we're going to create a collection. So you can see here there's one called create and create admin and config. So the first section here, we want to establish who the admin for this collection will be. I'm going to say that the admin for this collection will be Alice. The second section here is the bit flag section, which is the settings, which you can see if I backspace here, it's expecting a positive number. 0 means keep the default settings, which is what we're going to use for here. And then the next option is the max supply. So let's say I'm going to say, well, we can mint 25 NFTs. Another interesting section here, the mint settings, we have the mint type. So we can see that there's issuer, public, and holder of. So this is defining who can mint our NFTs. If we say issuer, that means that only the issuer is allowed to mint NFTs. If we say public, it means anyone can mint the NFT that we create. Okay, that we create a collection and then anyone can mint it. If we say holder of means, in this case, it would be holder of X collection, holder of which collection. So only holders of certain collections can mint NFTs in our collections. Okay, so depending on your use case, this may be interesting. So we're going to keep it at issuer. Price, I'm going to have it none. You can have a start block on which like NFTs can be minted, and an end block in which for the collection is live, and the end block where the collection, you know, you can't mint any more NFTs. Okay, and then default settings, we're going to keep that as a default as well. We can change that. You can look at the bit flags for that. So let's do this. So I'm going to mint this. Or I'm sorry, not mint. I'm going to create the collection. So submit transaction. Okay, it succeeded. So if we go here, recent events, we can see that the NFT collection was created. The creator is Alice and the owner is also Alice, right? And you can also see that the collection ID got incremented to 1. So the next collection that, if we were to create another collection, then it would be collection ID 1. The one that we created is 0. Okay, so the collection ID gets incremented every time we create a collection. So off-chain minting, right? So we now have a collection and we want to do this off-chain minting. There's an extrinsic here. It's called mint pre-signed. All right, so I'm giving this demo from the perspective of Polkadot.js, the Polkadot.js UI. You could also do this using JavaScript, right? Like Polkadot.js API using JavaScript. So the first step in off-chain minting is that we have to establish our mint data, right? What is the NFT that we want to mint, right? And it just so happens that this extrinsic gives us this UI that's actually quite handy for creating the mint data portion. So the steps that we want to do for off-chain minting, just to give you a high-level summary, we want to establish the mint data. We want to have our mint data, which includes the collection, the item ID, the attributes, if any, the metadata for that NFT, and some other attributes as well, right? We need to have that. Once we have that, we then encode that. So that's the second step. We got to encode the mint data. Once we have the encoded mint data, then we proceed to sign it by the issuer, right? The issuer is the one that has the approval. Like if we go back to that wiki, up here, issuer, right? We got issuer role. Well, the issuer is the one that can mint the pre-sign. They have the approval to sign that encoded mint data. Okay, so this UI is quite handy. So let's see. So it'll be collection 0 because that's what we just created. Item 0 because it's the first item in our collection. And just to give an example, I'm going to create an attribute here, name. I'm going to put my name. And I'm going to have just a blank metadata just for demo purposes. And then there's this interesting only account field here, which it's very, very, very interesting. So if we leave this blank, once we create this mint data, encode the mint data, and then sign it with the issuer signs this encoded mint data. Anyone who obtains this with this current setting here, anyone who obtains it could have mint that NFT, right? Via this extrinsic here, right? They would submit it. So that's the last step because it's set to none. All right. You could think like, well, why would we want that? That's kind of like anybody can mint that, right? Like that's kind of dangerous. Well, it really depends on your use case. Like I was talking to a colleague the other day, and he said that he could see a use case like this for like, say you're building a game, right? Your company has a game, and there's these hidden treasures in the game, right? And your character's walking around, and if you pick up and you find one of these hidden treasures, it happens to be one of these NFTs where the only account is set to none. And because you found it, anybody could have found it, right, in the game. But because if you found it, you can mint it, you can claim it, right? It's your NFT. So that's an interesting use case. There's a number of use cases where this could be useful. You can also set only account to a specific account, okay? And then that way you're whitelisting, you're saying only Bob can mint this NFT. All right, we're going to pre-sign this. Alice is going to pre-sign it because Alice is the issuer, but only Bob can claim it. Only Bob can mint it. All right, so depending on your use case, that could be useful. All right, and then deadline. Deadline in this case is until when this is valid, until when this can be claimed or minted, right? So it's actually a block number. So we want to be careful with this one. So for example, my node is running right now. It's at block 169. So I'm going to set it pretty far out. So I'm going to put like 2000. right? So it's valid up until block 2000. All right, so you can see that all of this so far consists of our mint data. All right, and as I was modifying this, the encoded call data here was changing. And at the end of the day, that's what we want. We want the encoded mint data. However, this is the encoded call data, which includes other things such as the signature, the signer, right? Because this is for this extrinsic here, which we're not ready yet to call, right? Because first we need to create this encoded mint data, sign it, and then we can submit it. So we only want the mint data portion of this encoded call. So with that, we got to sign it, right? So Polkadot.js UI has actually, if we go to the last tab here that I have, it has a section here called sign and verify, which is super useful. So we need to put in some, what we want, the encoded data that we want to sign, right? So I'm going to show you this, like just manual, like here's the encoded call details, right? We don't need everything. We don't need call index, and we don't need signature, signer, and link, right? So all we need is the mint data portion, which happens to be collection, item, and all these things here, right? So I'm going to manually show you this. It's going to be a bit tedious, but bear with me. So I'm getting the collection, and it's going to be hex. So let's get it here. The item, it's item 0. All right, so collection 0, item 0. We're just going to concatenate this. I think I can grab all of this at once like this. So the attributes, there could be, in our case, there's only one attribute. You could have several attributes. Metadata is blank for this one for demo purposes. Only account, we're allowing any account to be able to mint this, right? So maybe we're building a game. And the last one is the deadline, so that's 2000 encoded. So we're going to concatenate all of this together, make sure there's no spaces. And what this is our encoded mint data, right? So what I'm going to do with this encoded mint data is I'm going to sign it with Alice, because Alice is the issuer, right? So sign, and we get the signature. I'm going to copy that. Now we have, what do we have here? We have a pre-signed mint data, pre-signed encoded mint data, right? So if we go back here to the wiki, just to review again, the issuer mint pre-signed, mint an item by providing the issuer pre-signed approval. So that's what the PR said here, just to review, because it's a tricky topic. This PR adds a new way of minting NFTs with pre-signed data, right? So I can now take that signature, the signature here, it's the encoded mint data that's signed by Alice, the issuer. I can now use this extrinsic, and it's going to be SR25519, and paste it in there, the signature, and specify the signer, right? And submit transaction. Okay, it's in the block, recent blocks. Look at that. NFT issued. So collection 0, item 0, the owner is now Alice. Okay, and the attributes were also set. So that's off-chain minting, or what's known as off-chain minting. Okay, so the item just got minted. Like if we want, we can actually, let's go here to change state, NFTs palette. And if we see like, let's see here, maybe item, there it is. Okay, the item exists, and that's Alice's key. All right, so it's been minted. So just want to say here that like this is a feature that's like it's a brand new feature, part of this palette, and I really think that there's a lot of potential for off-chain minting. I haven't seen much out there like in the Web3 space about documentation or people using it. So I think this is a ripe feature to like really disrupt the NFT space. And from this, I believe we're going to see a lot of innovation, a lot of hybrid apps built around this, dApps. So I really look forward to all of you that are watching this that are thinking about building around this to use off-chain minting. And I also put together a written guide around this, the demo that I just did. So I'm going to actually see if I can publish this on Polkadot Forum. I also want to publish this in Stack Exchange. So just calling out here, Stack Exchange, Substrate, and Polkadot, like it's available to you as a Pallet developer, as a Substrate developer to use. Here's a question that was asked 1 month ago. How do you do off-chain minting? What is it? And there was a small guide here that Igor, the main developer, posted. I'm also going to be following up here with the step-by-step instructions that I just did. So if any of you want to see that, well, it's available. Okay, so I just have to prove that I'm not a robot, and boom, there it is. All right, so the instructions are there. That's available to you. The other thing that I want to say is NFTs, the roadmap for NFTs, it's being discussed on the Polkadot forum. So if you're not aware, like you're welcome to go in the Polkadot forum and discuss the future of NFTs. You can see Yegor there, the main developer that built the NFTs palette. He's active on there as well. So we welcome your feedback as you use this palette. We want to hear your feedback, right? Like, how is it working for you? Any ideas that you have? That's what the Polkadot forum is about. I also want to say that, like, how did you know? Like, how would a Substrate developer know that this feature came out, right? So this is also like, how do I say? I'm kind of marketing the idea of one of the things that we do here at Parity is we create a release analysis for every release on Polkadot. And this was on release 39 that the off-chain minting was released, right? So if you were following up on the Polkadot release analysis, you would have known, because down here, I actually wrote this one, so I'm proud of this, off-chain mint, right? So you would have known this back, when was this published? March 9th, right? So I'm right now in May 26th. So quite a while ago, you would have known about the off-chain minting feature, right? And you could have played around with it. So just to call out for the Polkadot release analysis, make sure you follow that. And the other thing that I also want to cover is when you're working with the NFTs palette, you could be using the palette itself. Another way of working with the NFTs palette is that perhaps you want to build your own palette that works with the NFT palette. And I think that's important to note, because depending on what you're building, that could make sense, that you want to create another palette that will couple with the NFT palette. And if you're interested in doing that, there is a palette that just got merged the other day. I believe I have it here. Let's see. Yeah. The NFT fractionalization palette is an excellent example of a palette that couples with the NFT palette. You can see here, there's palette NFTs, collection ID, palette NFTs, item ID. So it's coupled with an NFT palette. So if you're interested in building a palette that's coupled with an NFT palette, I recommend you take a look at the fractionalization palette that's now in the master branch. So it has some great use cases. For example, NFT palette is super, like, there's some really powerful features in there. One of them is that you can lock the NFT. So if you look here, the fractionalization palette actually uses that features off of the NFTs palette. It calls disable transfer. So we're doing here, we're locking NFTs. Okay, so we're actually calling a feature that's on the NFTs palette from another palette. So depending on what you're building, that could be really useful to say like, okay, I have this logic where I now need to lock my NFT, and in order to do my logic, right? So uh, there's a lot going on in the NFTs palette. All right. So I think, oh yeah, one last thing, and then I'll pass it over to Alexander. Um, the last thing that I want to show you is that just yesterday, the NFTs palette went live. There it is, NFTs on StateMine on Kusama, right? So StateMine is on Kusama. It's now live on Kusama on StateMine, right? So it's there in production for you all to build around it. All right. So really excited to see your work. Thank you. So hand it off to Alexander.
Thanks, Bruno. Uh, now, that was a great demo indeed. Now let's look into the source code and figure out the implementation details of this NFT palette. And as usual, it can be found in a Substrate project under the frame directory. So here it is, and you can see there are a bunch of files. And as Bruno said, this palette is really huge, so it's totally impossible to cover it line by line. We'll just focus on some of the things that I find interesting and how the palette is implemented. And the first thing we'll start with is this file, which is called impl non-fungibles. Those of you who saw a similar session a week ago already know what it is for. So Hector did a nice explanation of why this file is actually needed. It implements common traits for the palette, and the traits that we're actually interested in this particular case are this one. So there are two files called fungible and fungibles. So as it says in the comment, the first one, fungible without s ending, are the traits for dealing with a single non-fungible items. And as the guys already said, the NFT tokens, or how they're referred to as items here, are organized in forms of collection. So here are the traits that allow you to manipulate just a like a single item from this collection, so a single NFT token. And the second one, um, called fungibles, is a collection of traits for like manipulating NFTs at a collection level. So the traits that can be found here are the create trait that's responsible for creating a collection, destroy trait that's responsible for destroying of a collection, and so on. So you might be really interested in these traits if you're like, for example, implementing a palette, like an NFT palette of yourself, or like a more probable case if you are, like Bruno said, um, like coupling. So you're implementing a palette that uses um, NFT palette internally. So you're kind of coupling your palette with an NFT palette. So you will do it with help of these traits. Now going back to the source code, like we won't be covering configuration here because it's already was covered by Pavan. And so I think we'll start directly. We'll just jump into the extrinsics. And the first extrinsic that I want to start with is create. I think it's kind of straightforward that this extrinsic is responsible for the creation of a new collection. And in order to create a collection, you need to specify an administrator, like an account that will be administering the collection, and the collection configuration. So let's take a closer look at the configuration. So as you can see, it has like, it's a structure with three fields. Um, the first are the settings of the collection itself. So these are the bit flags that Brunner talked about so much. Um, so, and interesting thing here can be found in this is disabled function. So you'll see how it actually does the check. So if a corresponding bit is set within this bit flags field, then the feature is like is disabled. Okay, so if you specify 0 for this field, then it is thought like all the features are enabled. So this is by default. And if you're setting a particular bits, then the features are, this is how you disable features. The next thing is max supply, which is optional. So this is a kind of a limitation, the maximum number of items that can be within a collection. And mint settings, we'll talk a bit about it a bit later. But these are the default settings that will be applied to every item in a collection. Now going back, um, like the guys already said, the collection ID doesn't come from the arguments, but we already, like we pre-calculated for you. Here's how it happens. So we have a next collection ID. This is a storage value. And the type of this value is the collection ID specified in the configuration. And like along with the common traits, it has this one called incrementable. Incrementable gives you two functions. This function increments the value in place, and the initial value is like returns the default value for your collection ID, which is used for the very first time that the very first collection is created. So this is how we get the collection ID. Then we get an owner, get an admin. For the administrator, we actually get it through the lookup. For those of you who are unfamiliar with this thing, it's just a way to introduce an indirection over the blockchain accounts. So this is defined in systems palette, and just some kind of a mapping. So for example, it can be like indexes palette that allows to use both, like either the accounts on the blockchain itself or the like indexes, some small numbers associated with accounts on the blockchain. So that's it. The next thing we check whether this the deposit required like setting is enabled. Let's take a look at some of the extrinsics that I find interesting in this palette. Okay, the first one is the create extrinsic. Unfortunately, I don't know where my connection dropped, so I'll start with extrinsics. And here we can see next collection thing. Like Guy previously said, the collection ID doesn't come from the outer world. Just we have it pre-calculated. Okay, how is it implemented? We have a storage value with this collection ID type as a type of the storage, and the collection ID type has this incrementable trait that gives us two functions like increment, which increments the value in place, and the initial value, which gives us a default value for the very first time when the storage isn't initialized. Then we get an owner and administrator for the collection. And also caller of this extrinsic specifies a collection configuration. A collection configuration is structure that has three fields. One is collection settings, and collection settings are these bit flags that Bruno already covered. So if we take a look at this is disabled function, then we check that this kind of a disabled feature is checked um, with this following expression that checks if the corresponding bit actually present in his bit flags. So this means that by default the value is 0, which means that all the features are enabled, and if we set up the corresponding bit, this would disable one like a feature. So the next thing here is the max supply, which is kind of a limitation for the number of items that can present in a collection. And the mint settings, which are the default settings for every NFT being minted. And we'll have a look into it a little bit later. That's it for the create extrinsic. And as you can see, like a create extrinsic function also has this check. Okay, so we cannot create a collection with the deposit required setting being disabled. Okay, so we check for it. If we want to skip this check, we will have to use another extrinsic, which is called a force create extrinsic. And actually, like kind of every extrinsic here, almost every has a force companion that allows us to skip checks if needed. The next extrinsic that we're going to cover is the destroy extrinsic, which like makes the opposite thing. So it destroys a collection. And an interesting thing here is that its like complexity is kind of linear. So it's not executed as like big of one, but uh, that happens because when the collection is being destroyed, it iterates over items that are contained within this collection, and also there are multiple values um, because like different bits of data that corresponds to each item is held within a different storage. So let's take a closer look. Here is the internal like function that actually implements the logic. And so here are some checks. And here is actually where the fun starts. And we are iterating over like item to metadata mapping, and unreserving the currency that was used uh, to deposit. Like so, here is the one iterator that like justifies the first parameter in the weight, and here is the second one, and here is the third. So let's take a closer look at this map. As you can see, this is a double map. So this is kind of a map that has like two keys. And the good property of this thing is that we can iterate over it, like specifying only the first key. So it can give us like a way to optimize like the performance or like the storage. But you have to remember that if you specify the first key only, there's always iteration. So this function never it's like is always linear time. The next thing that's interesting here is this destroy witness argument. So when you are trying to destroy a collection, you have to specify destroy witness, which is a structure containing counters. These are actually the counters, the number of item in each of the collection we previously saw that needs to be removed. This is used as some sort of a verification that you're actually aware of what you're doing. So very similar to like you're removing a repository on GitHub, you have to type in the name of the repository that you're removing to make sure that you understand what you're doing. So the same idea is here with this destroy witness thing. The next extrinsic is the mint. So in order to mint a token, we need to specify a collection we are minting, an item ID. So here it's not like in the collection, the item ID comes from the user. And there's an optional parameter called witness data that we will talk about just now. So the minting is actually kind of straightforward. You just need to populate the corresponding storages. And the only interesting thing here is this mint settings that we kind of touched previously. So these are the mint settings I talked about before that are the default settings for every NFT token being minted. So and the parameters for these are the start block and the end block. So they define, as you can see here, they define a time slot when tokens within a collection just can be minted. Okay, so when I'm creating a collection, I can specify the time slot when I want the collection to be populated. The next interesting thing is the mint type. Bruno already covered it. The possible things are issuer, so when only an issuer can like create mint items. Public, when everyone can mint items, and the holder. Holder of is actually an interesting concept. Holder of allows you to mint tokens in this collection if you hold other tokens in a different collection. And the collection that we want to look into is specified here in this argument. And for this, so if our collection is of this type, holder of, this is when we need to specify this witness data argument. So we are providing the item ID that we own in this collection. So that is kind of interesting thing. And the last thing here, oh, I think that was it. So yeah, the last thing is this price field that we haven't talked about yet. So minting in a collection is not always free. So creator of the collection can specify this price field, and this would mean that he would need an minter of a token needs to transfer for minting a token in this collection. And in this case, transfer happens automatically. So the next thing that we'll talk about is the burn. I think it's quite straightforward. We won't be talking much about it. It's just does the opposite to minting. It's just burning a token, and for this we need to specify a collection ID and an item ID within this collection. Yeah, one more interesting extrinsic is the transfer. Transfer, as it can probably be understood from its name, transferred token from one account to another. And it also is a very kind of straightforward thing, despite two interesting things. So not only the owner can transfer the token, but there's these guys called approvals. So you can actually, if you're an owner, you can delegate these transfer capability to a different account, and someone listed in this approvals list will be able to transfer this token. And there is one interesting thing related to this in the source code. So when we transfer an NFT, we have to clear this approvals list. And there's a comment about this that says we are doing this in order to prevent the pre-approve attack, though it's not very clear probably what a pre-approve attack actually is. The thing is that I myself, while still being an owner, can add my another account to the approvals list and sell the token, so transfer it. And if we don't clear this list, then after selling my NFT, I would still be able to transfer it like back to me. So this is the pre-proof attack that we're talking about here. So this uh, thing here is kind of very, very important. And yeah, let's probably make a closer look at what these approvals are. So as you can see, the approvals are defined in the details, but this is kind of a generic. So let's take a closer look and see how it's been like typed. Here's the thing. So this approvals is a B-tree map. So it's a map, meaning that it allows us to do a mapping between from account ID to block number. So we can kind of specify multiple approvals, and the block number here is kind of a deadline that Bruno talked about before. So uh, we are delegating this functionality until the block number, until the deadline is hit, and our current block number is less than the one specified here. Okay. Next thing I'd like to, so I think we'll skip the rest of the extrinsics because we are really short on time. But they are very kind of technical and used for setting things here and there and just manipulating different parts, like you can manipulate the metadata, attributes, and so on. And the next interesting extrinsic I would like to talk about are these two guys, like set price and buy item. So what are these for? Is that you can actually sell. Okay, so this is done for trading. So you can sell your NFT right on the blockchain. Okay, so if you want to sell an NFT that you own, you call this extrinsic. You specify the item that you are selling, the price. As you can see, the price is an option. So the logic here, there's kind of split in the source code, and the logic here, if you specify the price, then you're setting the price. If you specify none for the price, then you are removing your offer. And you kind of can whitelist buyers here as well. And as soon as you call this extrinsic, your offer gets into the item price of storage. This would mean that this would indicate that you're actually selling your NFT. One more thing interesting here is this check in here. Okay, so the first check is that we are making sure that this trading feature is enabled. Okay, and here is a list of features that are supported in NFT Pallet. So these are trading that we're talking right now. The attributes, Bruno talked about it quite a lot and did a good overview of what it actually is. The approvals is a feature that we already kind of touched. These are the delegation of the transfer capabilities. And the next thing is swaps. So let's take a bit closer look on the swaps. And the swaps are the atomic swaps. Okay, so the swap is actually something is the situation when I want to exchange my NFT that I own to another NFT that I don't own. And the word atomic here means that we cannot, get stuck in between. So we cannot find ourselves in a situation when I transfer my NFTs to someone and someone doesn't transfer it back to me. So it either happens both ways or it doesn't happen at all. That's what atomic means here. And so if I want to swap an NFT that I own, and I call this extrinsic, I specify an item that I want to offer. an item that I want to get back, a price. Price is just a normal price, so it's just a balance, balance type with these extra like effect attached. Okay, let's take a closer look. So this is the amount, and this is the price direction. And the price direction can be two ways. It can be either send or receive, because the NFTs that we are exchanging, they can have different values. So we need kind of regulate that thing. And the duration, which is a mandatory. So it is the like a time slot. It specifies like the deadline, like we already covered before, when my offer is makes sense. Okay, and the two possible outcomes for swap creation is the cancellation in here. So I can either so the cancellation can happen actually in two ways. So either the deadline is hit. In this case, anyone can remove the swap offer, or if the deadline is not hit, then only an owner can remove a swap offer. And the claim swap is the situation when we have a buyer, or like we have someone who wants to exchange. Okay, and if I want to accept an offer for a swap, then I need to specify an item I'm sending, an item I'm receiving, and quite obviously a price. And I think that actually that's it. I try to do it as quickly as possible, but this is NFT palette in a nutshell. So
Okay, so I'll take over here. Let's see here. I want to show you something. Alexander quickly covered some of the code here. If you look at the NFTs palette, if you open up the folder, I actually want to point out that compared to other palettes, if you look at how other palettes are being developed, I really like the design here, like especially if you're building palettes yourself, to study this palette, because the way it's been broken up is interesting. It's very interesting, and it could be useful because, for example, we have a features folder, and you can see that we're grouping certain actions into features. So approvals, buy, sell. You can see like there, in the buy sell, there's the do by item, which is used in one of the extrinsics. So it's an interesting way to architect your palette and to make your palette smaller, right? So this was a question that's been asked more than once that I've seen out there, which is like, okay, I have my librs file and it's getting pretty big, right? Is there a way that I can like break it up into files, right? And this is one way, right? And it's a pretty interesting way because you can create features and you can start defining grouping things into features, and you have your functions, they're public functions, which they can be used in your dispatchables. So nice thing to study there. The other thing that I want to highlight is the fungibles here, the non-fungibles. So some of you may be aware of this, some of you may not be aware of it. Let's go here to the substrate docs. So, if you're a substrate developer, this should be your home. So fungibles. So let's see, non-fungibles, traits, tokens, non-fungibles v2. Okay, so this is available to you as a substrate developer. This is available to you, and it's quite useful. You can see that non-fungibles v2, these are traits for dealing with multiple collections of non-fungible items. So some of the traits that are available to you are create, destroy, inspect, mutate, and transfer, right? So if you look at, like, for example, create, you have create collection. And I believe in the code, if we go back to the code here, we can see some of this stuff. So let me make it one section larger here. You can see here that right here, we're implementing inspect, right? And inspect, we're defining here owner, right? That's pretty cool. And if we scroll down, there's some other functions that we're defining here as well. And then we get here, we're implementing create, right? So if we go back, here's create. We're just looking at create. So create collection. And you can see here, you know, we're doing an ensure. Deposit required can be disabled by calling the force create only. So we're making sure that the setting is correct. And then we're calling do create collection, which I bet is inside of feature. NFT source. Let's see here. It's do create collection, and then do create collection is defined right inside of features, right? So features, right here, features folder, create delete collection, and inside of that, we'll see that there's the do create collection. All right, so it's really nicely organized. This pallet's really nicely organized. It can be an inspiration also for those of you who are building your own pallets to study and review. All right, so the other last thing that I think is pretty cool that I want to show you actually has to do with my demo. And anytime that you're trying to understand something in Substrate, anytime that you're trying to understand how a pallet works, especially something like off-chain minting, I find for myself, it's really useful to look at the tests. Okay, and you can see there's a test in the test folder. There's a test called pre-signed mints should work. Right, so this is the off-chain minting portion. And I mean, it can't get better than this. Like, I don't really see much of a use for comments in here because it's super nice to read, right? Like, look at this. We're creating the Alice pair here, the Alice key pair, right? We got our signer, right? We then define the pre-signed mint data. So that mint data that we were talking about, like, this is easier to understand than the UI, right? Like, okay, collection 0, item 0. We set some attributes. We have some metadata. Anybody can mint this, right? Here's the deadline. You know, it's valid up until that block number, and that's our mint data. Which then the very next step, we simply encode it. We now have our encoded mint data. We then proceed to sign it with user pair 1, which happens to be Alice, right? So we're signing the encoded mint data here. We got our signature, and then we continue and we create. So it's like a story. You're reading this. It's so nice to read, right? And it's not only for this test. It's any of the tests in Substrate. So it's a little tip that I recommend for those of you who are working in Substrate. I hope you all enjoyed this presentation, and looking forward to your PRs. Looking forward to your parachains and your pallets. And really, we only covered the tip of the iceberg in terms of this pallet. Like, I don't think there's so much that could come out of this pallet, and I hope you get an opportunity to study it and think about it. Thank you.